Is there a digital logic question?
One group out of all the labs today finished the lab.
It's because I didn't get the video up until late.
I don't know. It was brutal.
Yeah.
The lab was brutal today. Just didn't know a little bit. I just got out of it.
Decoders suck.
Did anyone do the little shortcut that I told y'all to do, which would be like super quick?
We tried. We tried.
That was so easy though. Wait, hold on. Like,
Mr. Durden is on his way, he says.
so it was, I'll get to circuits in a second, hold on.
Brutal.
I have that to look forward to next semester.
It was just,
I'm trying to get them to take the lab off. You want the wrong option. Because we don't get taught how to code in Verilog because we only have class once a week.
Yeah, I find that pretty strange.
So you're just expected to either
okay, wait, hold on. I'm going to stop this recording. You'll only have start the recording. All right, so now here we are. We're at circuits. We're very happy because we love circuits. And we are doing some circuits. So much better than digital. No, I love digital logic. I know. Okay, so let me show you what I have done for y'all for circuits. So if you go to circuits and you go to SI resources, I wonder what that was that I thought I had posted that I've not posted. And you go to SI resources, what you will see is I had already posted the recordings from our first session. So those were there, and you have those recordings. And then I posted a second worksheet, and then I posted the problem that was at last night's session that I got two different answers, and I figured out the problem was that it's just a missing minus sign. But then I said, well, let me go ahead and solve this circuit. And it's the same circuit that I do with nodal analysis, mesh analysis, KVL, KCL, and also source transformation, which is something good for y'all to know later on. So that is a good one to look at to review all of your different methods. And then I went back and I found that I have this playlist that has recordings of most of the problems in that new worksheet. And so this has recordings from 2023 of all kinds of different things. And so you've got these available. So these are recordings that are answers, solutions to solutions to this worksheet. So if you're looking at this worksheet right here, that playlist has solutions to, I believe, everything on here, but maybe not everything on here. And we did some of these yesterday. So, so all of these you already have a solution to. So those are there. If I recall from previous years, y'all do not need to know how to do resistors like from the color bands. From the color bands, yeah, you'll eventually need to know that if you're going to be an electrical engineer, but you don't have to know it for this test, so you can skip that one. Okay, so that's what I have available for you, and I would like now, so I can do problems like the ones on that worksheet, and do them, and I'll probably do them differently than I did in the video, and so then you'll have two ways to look at it. Or I can do a different problem altogether, and then you'll have an extra problem to look at. So it's up to y'all what you want to do. Okay, so we'll do a different problem. I'll also be happy to answer any questions you might have. Am I sharing my screen? And if not, why haven't you told me?
I've just been looking at you. I don't know.
Oh, I'm not sharing my screen, am I? Okay. Golly.
More
Alright.
James.
No, that's not James's fault. Let's see. Let me see what the chat says. Where is the chat? Names. Thank you. Appreciate the names. All right. I think what I would like to do is I asked her what was going to be on the test, and she said everything up to superposition, no Thevenin or Norton. Let's do a quick resistor simplification just to make sure you can do a resistor simplification. So this one will be fun.
We're gonna check how much poison you just put in.
Check the macros after
All right. So let's use resistor simplification to find I and V naught. So V naught is the voltage across that 8 ohm resistor. So I'm going to say use resistor simplification and probably I would say and voltage division, but we'll get there. So what we want to do is make sure we can identify things that are in series and things that are in parallel. Okay, so let's take a look at this, and I am going to circle these resistors in different colors, and I want you to tell me the colors of any two resistors that are in series. Oh, that's the same. Let's see. That's brown. And this is some sort of yellow. Okay, tell me the colors of any two resistors that are in series.
with the red and white series.
The red and white ones are in series. Okay, can you tell me anything that is in parallel?
The pink and the brown.
The pink and the brown are in parallel. Is there anything else?
The purple, the brown, the gold, and the combined, the red and white would be in parallel.
You're close. The purple, the brown, and the gold, or pink, brown, and yellow, are definitely in parallel. Is the combined of the other one? Yeah, the combined of the other one is as well. The combined of the other one is as well. And here's how you can tell. If I look at this, the top end of this resistor and the top end of all of the other resistors, they're all connected without an element in between. And if I look at the bottom end of all of them, they're all connected without another resistor in between. That means they're all in parallel. Okay, so that means that this is the same as That's 10 volts. 2 ohms. And we'll just draw it a little nicer now. So we've got 8 ohms, 2 ohms, 8 ohms, and 8 ohms. Now, you cannot do product over sum with more than 2 resistors. So that's not how we can combine all of these in parallel. But a little shortcut I can use for these last two, if I have 2 identical resistors in parallel, then I know that the equivalent resistance is half. Resistors in parallel, the equivalent resistance is always less than either of the 2 original resistors. And if they are identical, it's going to be half. So those last two, the equivalent is 4. Now, to combine more than 2 things that are in parallel, you would do it as 1 over 8 plus 1 over 2 plus 1 over 4. So it's 1 over the sum of 1 over each of those. So that's 1 over 1/8 plus 4/8 plus 2/8, which is 1 over 7/8, which is 8/7. And so my equivalent resistance for all of those is 8/7, which is like 1.14, I think. 1.14. Y'all impressed? 1.143. Okay, I'm going to pause for a second and let people catch up. So, and I will have a cookie because we have cookies.
Of course.
Of course they're cookies because you're not here?
Yep.
Yep, that's why. How'd I know you weren't going to be here?
And then here's alarm.
4 o'clock every day.
It's just the same alarm I use to wake up. It's extra terrifying when it is.
It still terrifies me.
Anytime I hear it out in the open, it still freaks me out.
All right. So now I want to find the current. And so to find the current, I can treat these two as if they are in series. And so the current will, in this problem, just be the voltage, the voltage source will be our voltage. And our resistance will be 3.143. So our current is 10 over 3.143, which is 2. No, it is 3.18. 3.18 amps. Okay, so now the other part of this problem was to get the voltage across the 8 ohm resistor. So we wanted the voltage across the 8 ohm resistor. What is true about items in parallel? What is the same for items in parallel?
Sorry, voltage is the same.
Voltage is the same. Voltage is the same for items in parallel. So that means the voltage is the same for each of these resistors and for the equivalent resistance. And so I can find the voltage for this equivalent resistance, and it'll be the answer to my question. And so I'm going to do that with voltage division. And here's how voltage division works. What was that top one too? If I want the voltage across a given element that's in series with other elements, if I know the total voltage across the entire thing, so I know that across all of this is 10 volts. If I make the bottom ground, that's 0. It's 10 volts above, so there's 10 volts across the whole thing. So if I have something that looks like this, and this is how they'll draw it in electronics. Yeah. And I'm looking for the voltage across the voltage right here. Then to find the voltage across any one element, you take the total voltage, which is 10, times the element that you are interested in, which is 1.143, over the total resistance, which is 3.143. And I get 3.64 volts. So I get the voltage is 3.64 volts. Now, if I needed to get the voltage across the 2 ohm resistor, I could do the same thing and do 10 times 2 over 3.143. I am sharing my screen, right? Yes, I see it. Am I recording? Yes, I'm recording. Okay, great. So I could do the same thing. So I could do 10 times 2 over 3.143, and I would get 6.36. But I probably wouldn't do that because I would already have this in my calculator, and I would know that this number, the 3.64, and this number, whatever it's going to be, have to add together to be 10. So I would just subtract that number from 10 and get it that way. And if you subtract that number from 10, you get 6.36. So you get what you are supposed to get. Okay, so any questions on resistor simplification? And no? Okay. All right. Let me ask y'all this.